When working with triangles, it's important to remember that the angles correspond in terms of size based on the length of the sides as well. In other words, the longest side is opposite the largest angle. As a general rule, when dealing with the law of cosines to solve for an angle, it's a good idea to solve for the largest angle first. That way, if the largest angle is obtuse, you know the other two angles are acute. It can have at most one obtuse angle in a triangle. And if the largest angle is acute, we know the other two angles are also acute, because if the largest angle is acute, by definition, the other two must also be acute. Let's use the law of cosines, where we have three known sides, to determine the solution to a problem. If we want to determine the three angles for which a triangle that has a length of A3, B5, and C7. Well, if we could draw that picture, but because of our desire to solve for the largest angle first, we want to solve for angle C first. So we can use the form of the law of cosines, that C squared is equal to A squared plus B squared minus 2AB cosine of angle C. When we plug in our known values, we have 7 squared equals 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of C. We end up with 49 is equal to 34 minus 30 cosine of C. And when we further solve that, we get that the cosine of C is equal to negative 1/2. Because cosine is negative, if you remember from our quadrants, all the trig functions are positive here, sine is positive here, tangent and cosine. So we know we are in the second quadrant, which tells us we have an obtuse angle. And we know that that obtuse angle, either doing the inverse cosine of 1/2 on the calculator or using our reference angles, we determine that angle C is 120 degrees. Once we know angle C, we can then use either the law of sines or the law of cosines to determine A or B. I'm going to use the law of sines. I know the sine of A divided by 3 is going to be the sine of 120 divided by 7. So I get that the sine of A is approximately 0.37. Using the inverse function on my calculator, I know that the angle A is going to be 21.79 degrees, and then I can subtract both from 180 to get B being 38.21 degrees. As a second example of using the law of cosines, if I know two sides and the angle in between, I can use the law of cosines. If we have a sailboat that is traveling due east 11 kilometers, and then they create a 20-degree angle to proceed 15 kilometers, at what point they find the second buoy, and we want to know what bearing could they take or what angle could they proceed at to go from the starting point to the second buoy. Here's our current situation. If you look at this picture, you see they're traveling 11 miles. That's the length of one side, and then 15 miles. We know this angle is 20, which means this angle is 160. We want to determine angle A, but neither law allows us to do that directly. However, we can use the law of cosines to determine the length of side B there. And we can do that by finding B squared is equal to 11 squared plus 15 squared minus 2 times 11 times the cosine of B, or the cosine of 160. So we get that B squared is approximately 656.1, and so B is approximately 25.61 kilometers. Now that we know that, we can use the law of sines. The sine of A over 15 is equal to the sine of 160 over 25.61, resulting in a sine of A that is 0.2. And so the inverse sine then gives us that angle is 11.54 degrees. So instead of traveling 11 kilometers and then 15, they could simply travel 25 at an angle of 11.54 degrees from the starting point.